Assalamualaikum warahmatullahi ta'ala wabarakatuh. I am Ahmad Fazri bin Ma'zin from Faculty of Innovative Design and Technology, UNISZA. Would like to present my final year project, which is the development of cervical brace using the concept of self-balancing robot. This project is supervised by Dr. Nur Haiza binti Mak Yaakob from FRIT and Dr. Naresh Bashkaraj from Faculty of Health Science, UNISZA. Okay. Hollow brace is made normally from a metal type brace and attached to a patient with neck trauma to skull, used to strengthen the neck structure and stabilize the spine. It is used to prevent the movement of the bone of the cervical spine neck after a neck fracture or dislocation, to strengthen the neck structure itself and stabilize the spine and decrease the range of motion. So from the current cervical brace in the market, we found that the instability or weakness of instability happen when the structure of the neck cannot appropriately stabilize, and it also tends to get another fracture of cervical spine with very rigid and very tight range of motion that we give multiple problem to the patient for rehabilitation purpose. So we found that the 70% of the current product in the market contribute muscular fatigue, affecting 70% of people within their lifetime, and the tendency of cervical spine pain. This is also reported by Bromford, Evan and Nelson in 2001. So this project objective is to identify the effectiveness of existing hollow braces and to design a new concept of cervical brace using autonomous movement control. Then to integrate the Arduino design of self-balancing concept. Next is to test the functionality of new cervical brace. So this application is mainly for the home patient during rehab. This equipment will help automatically and give them a manageable of motion restricted tilt angle or limitation of movement set by their physician, compared to the previous current braces in the market. There is no other tools that able to control automatically for this patient. Then for the medical practices, this study of the new concept will give the assistant for a proper planning, special need, special function and development progress monitoring based on data provided from the artificial intelligence and computer science. And for the medical curriculum, the research also benefit as a alternative or a new strategy for rehabilitation equipment, rehabilitation procedure, therapeutic strategy for the home patient, and for the researcher, it also very benefit as a foundation to advert new artificial intelligence and computer science of modern learning theory, and the usage of big data that may help many people for continuously monitor their affected location for a different type of trauma. So novelty and inventiveness is the use of accelerometer and gyroscope for getting a measured data of the inclination angle, developing an Arduino PID controller for autonomous self-balancing chain and support platform. Then we have also the ability to integrate and control appropriate movement autonomously with a mechanical movement of servomotor of the new cervical brace development, which is the first in the world. So this is the final 3D model design with the Fusion 360 software, multiple view. Okay, Velcro strap hole, head support, bottom view, chest support. Okay, this is the final design of the 3D model. Um, the primary aim of this project, after going through the whole design from research concept and the development of the final prototype, so I presented to you the beta prototype self-balancing cervical brace, which is having a proper design of neck brace by using the correct joining method. Then commercialization potential, it also can be commercialized around the world as long there is a patient having a neck problem that need the cervical support at any group of ages. Okay, now we see how the product function. This you can see that existing what they have in the market after the hyobraces removal, they use soft collar. This use soft collar are folded around the neck with the velcro secure firmly and made of elastic polyurethane cloth around the neck, and that hold very firm. Then it also gives a very limitation of movement for a patient. Okay, this is how they remove the soft collar that need to be installed a new cervical brace. This is how they install the cervical brace. Very simple installation, only put below the chin and put on the velcro strap that is ready to use. Okay, this system is Arduino code programmable language that is interpreted and converted into machine language. Okay, so this movement is already connected with the Arduino language, then it's already transferred into PID to set the limit, to set the features, the capability of the setting required by the physician. So you can hear the sound of a servo motor working. They will not interfere the patient. Okay, this is how the new cervical brace hold the position of the head of the patient firmly and very effective holding position. This is how the servo respond when the chin tilt up and when the chin tilt down. So it's manually and automatically readjust the position into the level stated as O degree, 0 degree. So it will maintain the 0 degree position whether the tilting down and tilting up. So it's also very smooth movement of servo control, servo motor. So for this testing, we control the limit angle of minus 30 degree minimum and maximum 30 degree of the gyroscope angle, which is effectively utilized to detect and quantify an object deviation from ideal alignment. The set value time response is set to 50 microsecond. You can see the set value in the mean of activation signal of MPU 6050 in the response of 0 degree to 180 degree servo motor activation angle. So this servo motor activation angle, this we open from 0 degree to 180 degree, and in the middle is the tilting angle. Okay, So this is when we remove the setting from the Arduino, and this is a fully battery operated, fully mobile and fully battery operated portable device that providing data and cervical spine care for user individual setting capabilities. This battery energy and very energy density, we are using the lithium polymer lipo battery with DC supply 11.7 volt, which is the most effective power source that we found in terms of basic energy. And this shows that this device also very effective to the patient when they move around. Then the device also automatically will control the tilting angle of the head, tilt down and tilt up, so it will maintain at a stable 0 degree position. Okay, you can hear the sound, and this is where when the patient lying down on the bed, the proper position still maintained for these devices, and give the patient at very stable position device. So I think that's all from now. Thanks for my final year presentation, and you have any question, you may email me or give me a call for further clarification of the new cervical brace development using the concept of self-balancing. Thank you.